This is problem 59 for Model 1, and this is actually a homework problem, so I'm not going to do all of it, but we are going to look together at the motion diagram for this problem. So two automobiles are involved in a race over level ground. Both cars begin at rest. The Audi accelerates at A for t seconds, so let's put some of this down to make it easy to find later. So the Audi accelerates with an acceleration of A for t seconds, and then travels at a constant velocity, which means acceleration is 0 for the rest of the race. You get to pick the events on your own, but we'll put that in the table for now. The Buick accelerates at a over 2, so that's half the acceleration that the Audi has, for t2 seconds, but twice the time. And then travels at a constant velocity for the rest of the race. Determine the distance between the two cars at the instant 2t as a function of a and t. Okay, so I told you before that the events are going to be the same for both objects for all of the homework problems and example problems. And I didn't read the entire problem before I started putting things in my table, so this is actually going to be time t. This is going to be time t2 because they're asking about the distance at time t2. And then if this is t2, that means you still have an acceleration of a over 2 before event 3. Okay, so now we're going to draw the motion diagram. I'm going to start at 0, and it's a race, so they're both starting at the same place. And we're going to say this is positive, they're going in this direction. Since they're starting from us, the acceleration and velocity are in the same direction. Now I'm going to draw my motion diagram very carefully and use odd lengths for the velocity vectors for the Buick. And so the Buick is speeding up with an acceleration of a over 2. So we'll do 1 block, 3 blocks, 1, 2, 3, 4, 5 blocks, and 1, 2, 3, 4, 5, 6, 7 blocks. And I'm going to make this time 2t. And so if this is 2t, if you have 4 arrows going from 0 to 2t, then after 2 arrows, we're at time t. Okay, and this is for the Buick, which has the smaller acceleration. The acceleration of the Audi is twice the acceleration of the Buick. I gotta squeeze the acceleration for the Buick on here. So if we go from 1 to 3, we increased by 2. So this is the acceleration of the Buick. That's 2 blocks long. So the acceleration of the Audi should be twice that. That's 1, 2, 3, 4 blocks. Then for the acceleration of the Audi. And because the acceleration of the Audi is twice as much, the first velocity vector for the Audi should be twice what it is for the Buick. So that's 2. Then we add 4 to that, and we get 1, 2, 3, 4, 5, 6. So if your acceleration is twice as much, you just make all the arrows twice as long. But after 2 arrows, we are at time t. So since the time interval is always the same between 2 successive position points, after 2 arrows for the Audi, we would be at time t. So at time t, the Audi is here ahead of the Buick because the acceleration is greater. Now after this, the Audi continues to move with the same speed. But this length of 6, that was between this, that was the average velocity between this point and this point. So right at the beginning of the race, the velocity was 0. This is the average velocity between what you had right at this instant and the velocity that you have at this instant. So the average of 0 and what would give you 2. That means that velocity right at this point here is 4. And if this is 4, then what would the velocity be right at this point so that you get an average of 6? So the average of 4 and what gives you 6? That would be 8. So then right at this point, the velocity is 8. Since this vector is the average velocity between the instantaneous velocity here and the instantaneous velocity here. So we continue with 1, 2, 3, 4, 1, 2, 3, 4. That's one time interval, and you need another time interval to get to 2t, so that's 1, 2, 3, 4, 1, 2, 3, 4. So at 2t, the Audi is here. Since I was careful to do everything to scale, this distance here is actually to scale. So that distance is, this was 2 blocks here. So this is 1, 2, 3, 4, 5, 6, 7, 8 blocks. So from here to here is 8 blocks. This is 1, 2, 3, 4, 5, 6, 7, 8. And this is 1, 2, 3, 4, 5, 6, 7, 8. So I don't know what the units are, what 1 block represents, but I do know that this distance from here to here is 3.5 times as great as the distance from here to here. So you can see that just from looking at the motion diagram, if you draw it to scale. And if you do a good job doing your velocity versus time graphs for the Audi and the Buick, so the slope is the acceleration. So for the first part of the graph, from 0 to time capital T, this acceleration, this slope, should be twice as great as this slope. And then, I think I'll just do it for you so you can see what I mean. So this is the velocity, this is the time. I would suggest you do 2 separate graphs, but I'm going to put the Buick and the Audi on the same graph here. So this is T, this is 2T. We'll use blue for the Buick, which has an acceleration of a over 2 all the way up until time 2t. So that's for the Buick. For the Audi, you have twice the acceleration, so you end up here at the same velocity that the Buick has after time t. This is the Audi. Let's see if we can see this from the graph. So the Audi's velocity after accelerating was 8 blocks long. For the Buick, we were at, let's start here. If the average velocity here is 1 and this initial velocity is 0, the average of 0 and 2 gives you 1. This is 3. If this is 2, the average velocity is 3. And the velocity right at this point here, the instantaneous velocity at this point is 2. So the instantaneous velocity right at this point would be 4, because that averages 2, 3. And if you see the pattern here, instantaneous velocity at this point is 0. Average velocity is 1. Instantaneous velocity at this point is 2. Average is 3. Instantaneous velocity is 4. Average is 5. Instantaneous velocity is 6. Average is 7. So the instantaneous velocity right at this point, when the Buick begins to move at a constant speed, would also be 8. So after a time 2t, the Buick and the Audi are moving at the same speed. Well, the distance that the Audi has traveled is 3.5 times the distance that the Buick has traveled. Okay, so that's all that I'm going to show you for problem 59. After drawing the graph here, you can use the slope and the area to answer the question. You're determining the distance d between the two cars at the instance 2t, and then answer the questions here, and then you'll be done with problem 59.